Let us start with the model 3, that is a 7 site assessment. In the site assessment, it is very important to survey the site where the PV model should be installed. In there are two methods in which they install the PV arrays. One, it is on the roof, and second one, it is on the ground. And so proper data has to be collected and survey has to be done before installation of any model before installation of any model. And location is very important in many urban areas. If you see the city areas, the areas roof of the building is considered, and where the ground is available and the large ground are available far away from the urban areas. So roof specification, there are two things which we have to consider in the roof specification. First come the orientation means the maximum, it should receive the maximum sunlight sunlight on the roof. That is very important. By using the compass and magnetic declination data, we can install install the models on the roof. And the energy and the calculation also is very important here. We have to calculate how much the radiation it is going to receive, and how much the energy it is going to produce. Tilt angle, many of the roofs are not horizontal, so they will be in the tilt direction. So the tilt angle should be kept into the mind, because what happen, if it is a tilt angle, roof is a tilt angle, that it creates a lot of a problem. It creates a lot of problem. It sunlight received will be not properly. So proper care has to be taken, and angle should be found. Data has to be collected. See, you can see this is a tilt angle. For this one, if you see a flat surface, it is a completely tilt angle. So installation of a PV model becomes very important, in what way it has to be installed and how it has to be installed. You can see this one is in the south hemisphere and north hemisphere. This type of angle, tilt angle, it is taken. And this is the average daily electric production at a various tilt angle. The next topic is the shade is very important in this one. If you see that one PV models, dust will be there, dirt, dust, everything will be there, but it is unavoidable, that can be cleaned up. Some permanent sources of a shade will be there, that has to be taken care before the installation of a PV model. For example, tree and vegetation. If a trees are there nearby that PV models, then it is impossible to have a maximum efficiency. So the installation should be checked before it is done. Next, other buildings, nearby building, if a building is going to come, then it create a lot of problem. If shade is falling on the PV models, the efficiency decreases, the output also decrease, and it creates lot of problem. Later on, the PV model get damages. Some installation like chimneys, TV aerial, satellite dish should also be not there. If you see this, particularly this model, it is, trees are nearby that model, so it cannot produce a maximum efficiency in this one. And if you see another building, in this building installation are there. The problem is chimney, which is side of the solar modules. The shade is falling on the solar arrays, so efficiency decreases. So and another thing, natural landscape like mountain and hill also should not be there nearby that one. And care has to be taken that there should not be any shade, and analysis has to be done. New whatever the software that is available has to be used for the installer to see that installation should be done properly. See, there are many equipment from which the solar path, the shade can be find out. At what time it will come, on what day it will come, in what month also the shade will come on the panel. It can be find out, and the area, particular the site, can be examined for this purpose. So this method is called as solar pathfinder. In the solar pathfinder you can see this is the equipment which is using. This is the equipment which they are using to find out the path, the shade, whatever shade of particular object. If the in this one what happened, this is a line, this is a given. The first one is a magnetic declination, the first line. Second, the month of the year. And third is the time, time of the day. It shows when a tree falls or nearby any tree is there, and when this pathfinder it is kept in that area, then that time what happens, the shade falls, particularly falls on the dome. This dome or this equipment or instrument, when it falls on that one, it shows that what at what time in what month the shade will be there, and during the day what time the shade will come. So from this one we can come to know that in which month or in which timing the shade will fall. So it is placed on that side. And there are many software also which will show the time. If you take a particular photo of this dome and use that software, then it will show all the detailed diagram. So you can see this one in this particular year, one site is there, a site. You can see this one you can see they are using this one particularly. This is a dome, you can see this dome. Okay, this is a solar pathfinder. In this solar pathfinder you get lot of information regarding the shade, and you can calculate the efficiency of the a particular area. See, various types of tools are used for this one. The first solometric sun eye is a tool which is used. In this tool, what happens? It indicates it also indicates the shadow, the shade falling on the PV models. So here, what happened? Particularly, if picture is taken and the picture is fed into the software by you software, and the software will give lot of information. So another one tool is there, hurry catcher, that also is used to capture the photo. And with the help of the software the total calculation can be done. And iPhone apps, many iPhone apps also are there. You can see this one, it has been used. This is a solometric, this is a solometric sun eye which is used, and this is a hurry catcher. This is all used to find out the shade.